All right, in this video we're going to review naming of ionic compounds, and we're also going to extend our naming of ionic compounds to include not just monoatomic ions, those are ions made of one atom, but we're also going to extend it to polyatomic ions, which are ions that are made of more than one atom. And in order to understand how to do polyatomic ions, you're going to need to memorize a list of ions, their names, and their charges. But first, let's just review, naming ionic compounds and writing formulas for ionic compounds just using monoatomic ions. So let's say that I want to write the formula for iron 3 sulfide. So how do I write the formula for this? Well, the first thing we do is we notice that this is the name of the cation, and this is the name of the anion. We remember that the transition elements, those are the elements in this portion of the periodic table, can sometimes show more than one charge, and iron is indeed one of those. Let me get this a little closer to you so you can see where iron is. It's located right here on the periodic table. So iron, and that iron ion in this case, it's going to have a positive 3 charge. So I'm going to write Fe with a plus 3 charge, like that. And then the sulfide ion, that's just sulfur with an IDE ending. So this is going to be an ion that came from the sulfur atom. So to figure out its charge, we're going to look at the periodic table. We're going to find sulfur on the periodic table, which is right here. And keeping that in mind, it's seen right here, we recognize that sulfur usually gains 2 electrons. Remember, the atoms try to gain the number of electrons that are in this group right here, which is the noble gases. So sulfur is going to gain 2 electrons, and when it gains those 2 electrons, it becomes negatively 2 charged. So every atom in this column gains a negative 2 charge when it becomes an ion. So we'll pop that symbol and charge for sulfide. And then our next goal is to balance this. We need to balance the charges. Of course, 3 and 2, that's unbalanced. We've got to get the same number of positive charges as we do negative charges. So in order to do that, we're going to need to find the least common multiple of 3 and 2. Well, 3 times 2 is 6. Well, that means to get this to 6, I'm going to need to multiply it by 2. So I put a little subscript here. And to get this to equal a negative 6, I'm going to need to multiply it by 3, so I put a little subscript 3 here. And the formula, therefore, for iron 3 sulfide would be Fe2S3. In this compound, therefore, for every 2 iron ions, iron 3 ions specifically, there's going to be 3 sulfide ions. So that's going from name to formula. Let's do one where we're going from formula to name. So in this case, we're going to try lithium oxide. So we're going to go lithium oxide. All right, well, how do I do this? Well, I got to get my periodic table. I have to find the symbol and charge of the lithium ion. So I get my periodic table out, and I notice that lithium is going to be in that first column on the periodic table. And if it wants to gain the number of electrons as a noble gas, it's got to actually go from 3 to 2. It's actually got to lose 1, right? Remember, losers to the left, receivers to the right of this stair step here. And lithium atoms lose 1 electron to become lithium ions. So when it loses that 1 electron, it gains a positive 1 charge. So lithium in this case is going to be Li with a plus 1 charge. What about oxide? Well, that's oxygen with an IDE ending, which is in this group. Similar to sulfur, it's going to want to gain 2 electrons to become an ion, an anion in this case because it's negatively charged. So So of course it's going to gain a negative 2 charge. So we have to write O2 minus. Now we have to balance these charges. And in order to do that, the lowest common multiple of 1 and 2, well, that's going to be 2, right? 2 times 1 is 2. So I need to multiply this by 2 and this by 1. So the way we write the formula for this is Li2O. We don't write a subscript 1 here because the 1 is understood. And this would be the formula for lithium oxide. Oh, I guess that's another example of name to formula. What we want to do, sorry about that, what we want to do is do an example of formula to name. So let me try this one. Let's see. We're going to go with, let's try this formula here. MnO2. How would we name this thing? Well, we're going to name the name of the cation, and then we're going to name the name of the anion. The anion's pretty easy, right? We're familiar with this, I hope. This is an oxygen atom that's become an ion. So it's going to be the oxide ion. This would be the manganese ion, but the issue is here, because manganese is a transition element. You'll find it right here in the middle of the top row of the transition elements. That's manganese. We've got to tell folks what's the charge on this manganese. How do we figure that out? Well, we know that oxygen, when it becomes an ion, it goes 2 minus. Negative 2 charge. And because there's 2 of them, that's a total of negative 4 charge that we have in this compound. Well, what do we need to balance that? I've only got 1 manganese, and that single manganese has to balance this negative 4 charge, so it should be fairly obvious that we want to give it a plus 4 charge. So we're going to have a manganese 4 ion, and that's what we call it. Manganese. The way you write 4 in Roman numerals is IV, so it's manganese 4 oxide, which would be the name of this particular compound here. Let's try one more, and then we'll move on to polyatomic ions. All right, this one is going to be Al2O3. Al2O3, I have to name this. Well, this one's actually kind of nice because this is not a transition element, so this charge is going to be fixed. There's only one type of aluminum ion that's made. Again, we have oxide over here, so it's pretty easy to name this one. If I don't have to worry about the charges, I just name the cation, and the cations keep the same name as the atom, so this is going to be aluminum, designating the aluminum ions that are in the compound. And then we just name the the anion, which is going to be oxide. So this particular compound would have the name aluminum oxide. And this is indeed the way that you name ionic compounds. You simply first name the cation, and then you name the anion.